The section that we're going to be discussing today is section 1.4, which is powers and exponents, and our objective is to simply simplify expressions containing exponents. And so I'm going to give you the basics of how to do that and what each part of an exponent and a power is. So the first thing is we need to talk about how we actually write exponents. And so the exponent that we have, so the exponent tells how many times to use the base as a factor, and we know what a factor is, and this is what we call a power. And so what we need to look at is we need to look at each one of these things. So this whole thing right here, this entire thing, this is what we call a power. Now it's commonly referred to as an exponent, but it's technically not an exponent. That whole thing is a power, and it has different pieces. The larger number here, this is the base, and the small number over here, this is the exponent. So when we talk about an exponent, we're really talking about the small number, or we call it a superscript because it's above everything else, but that little number there is what we call the exponent. And the way that we say this power is we actually use the word phrase right here, 2 to the 4th power. So that's how we would talk about it. So it's the base to the exponent's power, and so 2 to the 4th power. And then so what that means is we take the base, and then if you see, every time we multiply the base by itself, and the exponent tells us how many times we do that. So this is 4, and so we have 1, 2, 3, 4 of the 2 multiplied by itself, which in this case gives us 16 once we do all that multiplication. So this is just kind of the basics of what a power is and how we talk about exponents. And so we have this idea that we can convert from one thing to the other. And so what this one is here is this is negative 5 to the 2nd power, which is actually negative 5 times 5. And we'll talk about what that is in a little bit. And then this one down here, 2/3 to the power of 6, gives us 2/3 times 2/3 times 2/3 times 2/3 times 2/3, and then times 2/3 again, so it's times 6 times. Now we could simplify that if we wanted to. This down here is negative 3 times negative 3 times negative 3, because what I'm doing is I'm taking the base, and usually we can signify the base with whatever in the parentheses, and that's what helps us. Here, in this case, the 5 is the base. The negative is not really associated with this 5 because the order of operations tells us that we have to do this a little bit differently, and we'll talk about order of operations as we move forward. But what we have here is the base here, the base is equal to 5, the base here is equal to negative 3, and that's the difference there. Now we can go the flip side of this, and we can convert these factors into powers. So we have 1, 2, 3 4s multiplied by themselves, so we have 4 to the power of 3. Here we have 24. Well, what we can do here is we can't really convert this to a power, but what we can write this as is 24 to the power of 1. And then we have 1, 2, 3, 4, 5 6s, so this is 6 to the power of 5. And that's how we can convert from exponents to factors, and then from factors to exponents. Now we typically talk about exponents representing areas and volumes. So if we have a square here, and it has a side length a, this is also side length a. And so we can represent the area of this square as a times a, or a to the 2nd power. And this is why that we refer to this as actually a squared, because it's really taking the principle of using a square. Now the same thing here, if we have side length a on this cube, all these sides are the same. And if I want to find the volume, I take a times a times a, and that gives me a to the 3rd power, or what we call a cubed. So pretty much everything else except for the 2nd power and the 3rd power we can refer to as squared or cubed. And this is just a kind of a short explanation of why that works. And just a couple hints. So if we have any number to the power of 1, so we have any number that has an exponent of 1 is itself. So if we have 3 to the 1st power is 3. 4 to the 1st power is 4. And then we say 100,000 to the 1st power is 100,000. So anytime you have an exponent of 1, it's always that specific number. So 3 to the first power is 3, 4 to the first power is 4, and so on and so on. And then on the other side of this, any number that has the power of 0 or an exponent of 0 is always equal to 1, because this is kind of the same thing as saying, well, I'm multiplying this number by itself no times, and the only thing that's left over is 1. So 3 to the 0 power is 1, 4 to the 0 power is 1, 100,000 to the 0 power is also 1. So any number to the power of 1 is itself, and any number to the power of 0 is equal to 1. And again, like I said, we were going to talk about this problem here, is that this is a common misconception, that we think that negative 5 to the second power is 25. But in fact, it is negative 25. And then here, negative 5 to the second power, this one actually is 25. So if you have a calculator handy, what I would like you to do is pause the video and go ahead and enter those two things exactly like you see them into your calculator. Now, the reason behind this is that when we talk about order of operations, and if you're familiar with order of operations, which this is a couple sections that will work with this, but our base in this case is actually 5. The only way that I would know that my base is something different than 5, because it's the number that's kind of attached with this exponent, the only thing that it would be different with is that if it had a set of parentheses, because this is telling me that my base is everything that's connected to this exponent. Well, it's everything inside of this parentheses. But on the other side of it, since this doesn't have parentheses connected to it, the only number that's associated with this exponent is the 5, because it's actually kind of with the 5. And so what we would do is we would take this piece first and do this part, so 5 to the second power, and so you would get negative 5 times 5, leaving that negative on the outside, which is then going to give us negative 25. And we'll talk a little bit more about this, and once we get into order of operations, it might make a little sense. But make sure that when you're looking at these exponents and you're looking at these powers, if the negative is not in parentheses, then it's probably not going to be a negative value. And so the next thing that we can do is another example of how we can use powers and everything like that. We can write numbers using exponents instead. So I want you to be able to write the number 8 using exponents instead. But I'm going to tell you that you're going to use a base of 2. And so what this means is 2 to the something power that we have up here is going to be equal to 8. So we can think about what that might be. And we come to the conclusion that 2 to the third power is going to give us 8, because 2 times 2 times 2 is 8. And therefore that we get 2 to the third power, or 2 cubed. Same thing over here. We want to know negative 5, and we're going to put this in parentheses, kind of like what we talked about before. To the something power is going to give us a negative 125. Now, based on what we know about negative values and odds and even values, we start with a negative 5. So we're going to be multiplying negative 5 a bunch of times. In order for me to get a negative value back using this negative 5, I have to multiply an odd number of times. So this value that's here is going to be an odd value. And so I can kind of think of some. So I know that if I just take these along, negative 5 times negative 5 gives me positive 25. And then we can keep going. Times negative 5 actually gives me negative 125. So I'm already there. So I multiplied negative 5 3 different times. And so this answer is negative 5 to the power of 3. Now again, like I told you, this number here is odd, because that's the only way that I can get a negative value after multiplying a negative number multiple times, because it's going to be a negative times a negative gives me positive, times a negative gives me negative, times another negative gives me positive, and so it kind of alternates between positive and negative, whether it's odd or even. And so one of the last things that we can do is we can compare powers of their values. And so what we can do is we could get a calculator and we could enter these in if we wanted to, or we could just multiply them out. And so what we can look at is we can look at what the value of these two things are. So we can kind of decide whether one is less than, greater than, or if they're equal to each other. And so this one, 10 to the second power, is 10 times 10, which is 100. This here is 2 times 2 times 2 times 2 times 2 times 2, which ends up giving me 64. And so we know that 100 is bigger than 64, so we can put our greater than symbol in there, so 100 is greater than 64. So we go back to our original problem and we say 10 to the second power is greater than 2 to the sixth power. Down here we can kind of work the same thing. So 5 to the second power gives us 5 times 5, which is 25. Here we have 2 times 2 times 2 times 2 times 2, which ends up giving me 32. And so we can look at this and say, well, we know 32 is larger, so 25 is less than 32. So that means 5 to the second power is less than 2 to the fifth power. So in some cases, usually what happens is the larger the exponent, the larger the number is going to end up being. So even though the base number might be bigger, doesn't necessarily guarantee that with a larger exponent that it'll be smaller or bigger. So you just kind of have to work through those. Typically, as you get larger and larger exponent values, so as this number gets larger and larger and larger, the larger exponent, regardless of what the base is going to be better. So if you have a larger exponent and even the base is smaller, sometimes that's going to be the bigger number. The last thing is I challenge you to write these as powers. So given what this information is, convert between powers and factors and powers, and see if you can come up with the right answer here. So you can go ahead and pause this video, and then what you'll eventually find out is that this is 2 times 2 times 2 times 2 times 2 times 2, because each one of these corresponds with each group here. And then all together, we get 1, 2, 3, 4, 5, 6, 2, so this is 2 to the power of 6. And if you look at this, you might be able to figure out something that's kind of leading you to that answer. Here, now we have to be careful of what we're actually doing. This is negative 4 times 4 times negative 4 times 4 times negative 4 times 4, because the base here is actually 4, not negative 4. So we have 1, 2, 3 negatives, so my answer is going to be negative. 1, 2, 3, 4, 5, 6, 4, so this is negative 4 to the sixth power is my final answer. And if you don't believe me, go ahead and put that into a calculator just like that, and you'll see that this is negative 4 to the sixth power. And this is 2 to the sixth power. And that's it for this video.